We integrate that and you get 9.8 T plus C.
Okay.
So now we know that V of 0 equals -6. So that's -6 equals 9.8 times 0 plus C. 9.8 times 0 is 0. C equals -6.
Okay.
So we got V of T equals 9.8 minus T minus 6. And so just like in the previous problem, we have to integrate this. So we're going to integrate 9.8 T minus so just like before, it's 9.8 T squared over 2 minus 6T plus C.
Okay.
All right, so then it's 4.9 T squared minus 6T plus C. Like that. And then I'm sorry, this is now S, not V. Sorry. So when you integrate V, you get position. So and we're going to use the S of 0 equals 0. 0 equals 4.9 times 0 squared minus 6 times 0 plus C. So it ends up that C equals 0, like that.
Okay. So I don't need to put 9. I don't need to add 0 to the end. I can just put it as
No.
9.8 T squared minus 6T. Okay.
So yeah, it's so your final answer is the 4.9 T squared minus 6T. That's the final. The 15, I guess we can do, but I mean, you can always tell me to skip problems if you feel like you can figure them out on your own.
Mm-hmm. I
Um,
could probably figure it out on my own. I go through and I screenshot everything. So
okay,
I could do that one on my own. Yeah.
got it. All right, so let's look at 16. So the critical points of this function are where the derivative is equal to 0. Where 3x times x minus 3 equals 0, where 3x equals 0 and x minus 3 equals 0. Divide by 3, so x equals 0, x equals 3. So those are the um, that's A, 0, 0, 3.
Okay.
All right. Determine where it's increasing or decreasing. So the way to do that in part B, let me snip that in, is you really need to look at what's called a sign chart here. So you put the points 0 and 3 on a sign chart. That's the derivative. So what you do is you actually go back to this 3x times x minus 3, and you test points. You test
Okay.
numbers that are in between. So like -1 is less than 0, to the left of 0. 1 is between 0 and 3, and then 5 is here. So what you do is you put those values back in the derivative right here, the given derivative, and then you test its sign. So what a lot of students do is they actually want to get a value out, which is okay. Like when you put 5 in here, it's 5 minus 3, which is 2. 3 times 5 is 15. 15 times 2 is 30. So this is positive. And we care that it's positive because it's increasing. All right. And 0 to 3 is 1. So 1 minus 3 is -2. 3 times 1 is 3. 3 times -2 is -6. It's decreasing. All right. And then -1. -1 here. 3 times -1 is -3. -1 minus 3 is -4. -3 times -4 is 12. So it's positive in here. And where it's positive, it's increasing.
Okay.
So in terms of how to answer, there's like so many bubbles. Here. It's like, what do we fill in? So it is increasing and it is decreasing. That's B. It's increasing. And this thing goes from -infinity to infinity.
Okay.
So it's increasing from -infinity to 0. Union, it says commas, use commas to separate. 3 to infinity. And then 0 to 3 is where it's decreasing. So typically it's all the intervals, it's going to be like this one, this one, this one. You just got to fill them in, where they go.
Yeah.
Right. So now mins and maxes. The mins and maxes. So if you go from a plus to a minus, okay, that's a max. And you go from a minus to a plus, that's a min.
Okay.
So if we go back to the sign chart, a plus to a minus, there's a max at 0. So in part C, where it says determine the local max, well,
Mhm.
it's where x equals 0.
Okay.
Okay. Minus to plus is a min. So if you look at the sign chart again, see how it goes from minus to plus at 3, that's a min.
Good.
So one of the reasons I put these test points down here is that you don't like confuse them. Like after you test, you don't need to do that. So the local min um, local min is at 3, like that.
Okay.
All right, so the next one here is this graph. One of the things about the graph that I'm trying to look for, and I don't see it, is whether it's the original function or not.
It doesn't.
So it looks like it is. It's the original function. So because the rules for increasing and decreasing are different in the original function. So you look for these peaks and these valleys. So it's increasing here, it's decreasing here, increasing here, and decreasing here. All right. The function is increasing on the open interval. So -8 comma -4, 0 comma 4, and that's it. So increasing means it's going up and to the right. Does that make sense?
Yeah, that's with union, right?
It says to use comma, so you always got to read the, like I would do that too. I think, oh, it's union, but it's comma in this case. The next one here is decreasing. Decreasing is from -4 to 0, comma 4 to 8.
Okay.
Okay, next one here is the absolute max. So it's kind of like we just keep going back to the graph to answer these questions. So the absolute max is where, like, wherever the biggest, tallest point is. And you can see it's up here. It's at -4 comma 6. And you can see in the way that it wants you to write the answer, it says use an ordered pair, -4 comma 6. Now there could be more than one. That's why it says use a comma, but there's only one peak in this case. Actually, it does not ask. I guess at the local max. Okay. So next thing is the local max.
Okay.
So the local max is um hmm, okay, it does say that. All right. It says do not include the absolute max. I was about to say, like, that is a local max, but they say not to include that. So a local max is like a place that's higher than everything else around it. So like this right over here, this 4 comma 0 is a local max because it's higher than the places around it.
Okay.
Now, let's do that. Yeah, we'll just do that 4 comma 0. And then the apps, oh, it is avoiding that issue. Okay. There's this weird kind of local max, local min problem that this one avoids it. So the absolute min is the smallest places on here. So the smallest place right here is right there at 8, -4.
Yeah.
So that takes care of that. Give me just a moment here.
Yeah.
Need to actually fire off a quick email here. All right, so let's keep going here. See if we can get this. You can see like some of these just move so slow. Oh boy. Yeah, I mean, I'm worried we're not gonna get through everything in this hour, so
Mhm.
boy, these are all so long.
If the next, I think the next two are really similar to the one we're doing. Oh, the next one's really similar to what we're doing, so you don't need to do 18.
Okay, and you can always graph these to answer a lot of the questions.
Yeah.
Just as a, you know, suggestion here. So 19, okay. Um, yeah, so let me look at 19. All right. So the derivative here,
Mm-hmm.
um, it says that the derivative is greater than 0 when x is less than 5. So let's say that that's 5 right there. I'm sorry, greater than 0. So what that means is it's increasing. The function is increasing, and then it's decreasing. So it's going up and going down. So you're
Okay.
looking for the graph that goes up and then goes down. Kind of looks like it's C or D, but I can't tell because of their kind of cutoffs. I don't.
Yeah.
No, I'm
Oh,
sorry. It looks like it's C. I would say it's
yeah, it's
probably
on
C.
the positive side of the graph.
There
Yeah.
you go. There you go. Okay. All right. So now, um, part part B, part B. Part B is similar here. It's saying that it's decreasing and then it's increasing. So, you know, it's like, okay, again, there's that dividing point. So it's decreasing. That means it's going down, and then it's
Mhm.
increasing. So um, it's decreasing and then increasing like that, something like that. It
Okay.
kind of again looks like it's
See.
could be, yeah, looks like it's C again. Yeah. All right. So the part C here, it says that the derivative is always increasing. This means the function is always increasing. It's always going up and to the right. That's what this language means. So um, it looks like it's either A or D. So the right here at 5 is where you're seeing this kind of this horizontal.
Yeah. It's D.
Yes. All right. So B is going the other direction, basically.
Yeah.
I think you can probably figure that
Yeah.
out as well.
It's C. Yeah.
Uh, so again, I mean, 20 you can absolutely do with you could graph it and answer all the
Okay.
questions.
That's
I mean, we always come back, right? You know, if that's an issue. Same with 21, 22. Like all these you can graph, but I mean, should we do some of these other ones first, or
We
do you,
can,
what do you
I'm
want us to do?
trying to see.
You tell me where to go.
Maybe we can start with 23 since that's something different, I guess.
Okay. So, um, first derivative of continuous function is given, find the second derivative. So I'll let you try that part. What's the derivative? You just got to find the derivative of the function here.
1 minus 2x.
1 minus 2x, good. Okay.
And that's
So
the
the
first,
reason, sorry, good.
I think that's the first derivative. Oh, wait, the first derivative.
Yeah, they're
Oh,
giving me the first derivative. To find the second derivative, you have to like this.
okay.
So the reason you get the second derivative is when you set it equal to 0, that is
Mhm.
typically an inflection point. So this is at x equals 1/2. X equals 1/2. So that means there's some sort of a change in concavity, from concave up to concave down, or concave down to concave. Okay, so when you look at the graphs, um, let me look at the first three. First three here. So this one's concave up, then concave down. This one is concave up, then concave down. Although it looks like A's change in inflections at 0, but it's hard to tell, really hard to tell. B looks to be slightly off center. But again, it's kind of hard to tell with these B and C. The other thing here is that you can do the sign chart thing again. Where you say, okay, there's 1/2.
Mhm.
And we're going to test some points. We're going to test like 0 and 1, and we're going to test them back in its original function. So can you tell me when you put 0 in, whether it's positive or negative?
It'd be it'd be positive.
Positive, and how about 1?
It'd be negative.
There you go. Now it's concave up when it's
Mhm.
positive, and it's concave down when it's negative. Is that okay?
Yeah.
All right. So that helps to answer some of these questions. So it's concave up, concave down. So it can't be C, but it could be A because it's up and then down like that.
Mhm.
All right. So we're down to A and B, and it's like, which one do we choose? If you just wanted to choose one, I'd go with B because it looked like it's slightly off center there, and A isn't. But if you want to do it for sure, we need to go back to the first derivative and figure out if it has more than one. Go back to the first derivative here and figure out if it has more than one 0.
Okay.
And like to be clear, what that means is minus x squared plus x plus 6. Like, let's say you factored out a negative. You got x squared minus x minus 6, x minus 3, x plus 2, stuff like that. So equals 0, um, x equals 3, and x equals minus 2. Those are your places where the original graph is going to have a horizontal tangent. And you
Okay.
can see how B has 2 of them.
Okay.
Since it's like maybe thought that was gonna to be faster, but it really wasn't.
Yeah.
All right, so let's look at 24. 24 here. Um, First derivative of a continuous function is given by this function here. Find the second derivative. So um, the best way to do this is actually distribute the x in first. So it's 3x minus x cubed, and
Okay.
then take its derivative. So um,
It'd be um 3 minus 3x squared.
give me just a moment, please. All right, so uh, the you got the derivative, that's good for that. Now, the next thing is to set this equal to 0 and figure out where the possible inflection points are,
Okay.
second derivative. So there's going to be 2 x values.
Would it be plus or minus 1?
Plus or minus 1. Now we should make a sign chart though. So -1 and 1 like that. And then 0, 2, and then -2 like that.
Okay.
All right, so go ahead and test these in this one right here and figure out what the signs are.
-2 would be negative.
Okay.
0 would be positive. 2 would be negative.
So there is an inflection point at -1 and 1. So you're
Okay.
looking for a graph that switches from concave up to it's concave down, then it's concave up, then it's concave down. So, concave down, then it's concave up, then it's concave down. So is there a graph that looks like that in those four?
Yeah, it's C.
It is, yeah. But sometimes you don't have to like go back and do the derivative stuff.
Mm-hmm.
So we can go to 25.
Yeah.
Right. First, second derivatives. Okay. So the thing here that I think could be this is kind of a complicated question to look at, but it's telling you that the second derivative
Okay.
is a line, okay? And really all we care about is where the second derivative is equal to 0.
Okay.
All right, so it's 0 right there, which means that there's a change in concavity from concave up to concave down at that point. So the original graph is going to have some sort of like up and then down shape right there where that place is right there. So do you see any possible ones that could be that way?
Yeah, C. That's what I see.
Could also be A.
Oh, yes. Yes.
All right, so then now it's like, well, what do we do? So it's kind of the same thing here. You look at the first derivative. Where is the first derivative equal to 0? Well, it's equal to 0 there and there. So the graph goes from the original function is decreasing, then it's increasing, then it's decreasing.
Mm-hmm.
So it's decreasing and then it's increasing and then it's decreasing, but it has to happen at that same point where the inflection occurs.
Okay.
So I think like if you're looking between A and C, that's a little bit or the tech, but you basically want to like draw a line up from there and like decide, is that where it's changing? Like I said, is it going from where did I write that? I don't know where I wrote that. Okay, so it's sorry, not there. It's right there where it hits. See how it's going? It's decreasing. That's this part right here. And then it's increasing the blue.
Mm-hmm.
That's this part right here. And then where it hits again here goes down to decreasing.
So So it'd be A.
I believe it's A.
Okay.
So now we got plenty of time here to go back and look at some other questions. I guess we skipped a few. So why don't you just tell me which one you'd like us to start with going backwards.
Maybe 22.
All right. Okay, so 22. Is it okay if I graph it? Because it says
Yeah,
to
of course.
graph. Okay. It can be done by hand, but it's like you do a
Yeah.
lot of things by hand, but why would you? All right, so one of the things that's important to do when you graph it by hand or graph it is to identify kind of the peaks and valleys. And so that most of the challenge for students is to like figure out that window to graph it in. You can see this goes up pretty high here, but you really need kind of these peaks, and then these go down forever. So the stuff that you can tell right away is kind of like mins and maxes and critical points and things like that. So let me just look here. So yeah, so the first question asks for the local min. The local min. So it's like, is there anywhere where like at one of these critical points where it's smaller than everywhere else? And this does not count. This does not count. This is called a horizontal tangent.
Okay.
So it does not count here. So the oh, I'm sorry, max. Sorry. So the local max, sorry, this is a local max, even though it's also an absolute max.
Okay.
All right, so that's, I guess I would go with 6 comma 1,296 like that.
Okay.
Let's see here, local min. So there is no local min. That's what I was trying to say, but I misread it. Because there's no place like a local min is where it kind of it has to come down and be lower than everything else. So there is none in this case because there's no place in the graph where it kind of comes down and then back up. It's always kind of peaking, and then these go down forever. So those are there's no absolute min either because these go down forever, and you're looking for a place where it actually bottoms out completely for an
Okay.
absolute min. Sorry, there's a better explanation for all this, but it's like we're just
Yeah.
yeah. So absolute max, we've actually already identified. It's the same as the local max, the 6 comma 1296. Um,
So there's no local minimum either.
yeah, there's no local min either. That's right.
Okay.
Now for the inflection points, unfortunately, you do have to actually take 2 derivatives,
Okay.
which is really annoying because it's a tough, it's you know,
Yeah.
you can't get that from the graph. So you do actually have to go back to your calculus here, which is 24x cubed minus 3x to the 4th. So 72x squared minus 12x cubed. And then take another derivative. 144x minus 36x squared. The y triple prime, I'm sorry, we don't need that, sorry, that's different class. So you have to set this equal to 0, factor out the 36x, 4 minus x equals 0, and set these 2 points equal to 0. So x equals 0 and x equals 4. 36x, x equals 0, 4 minus x equals 0, x equals 4, like that.
Okay. Type in ordered pair. 0, 4.
Oh, isn't it an ordered pair? Okay, that's not
Yeah.
good. So that means you have to go back to the original and you
Mhm.
have to put that point into the original. So it's in the, so the first one is 0, 0. The next one is 4 squared minus 4 cubed, like that. Or I'm sorry, you have to put in 72, 4 squared minus minus 12 times 4 cubed. So if you want to calculate that for us, please.
Uh, 3,840.
All right, let me check the graph here. It's not that large. Do that calculation one more time. I think maybe you just got a sign error in there.
$384.
I got it, different. Oh, you know what? I'm putting them in the wrong. That's the problem. You got to go back to the original, not the. So
Okay,
that's my fault. Sorry about that.
that's okay.
4 cubed minus 3 times 4 to the 4th. It ends up being 768. I'm using the graph, so it's like, I can quickly look for it. All right, where should we go from here?
I think there's a part showing where the graph is, and I think it's D.
Let me look here. Yeah, so I can't tell. I think it's D as well.
Okay,
Just kind of looking at.
yeah. But other than that, that's okay. I think I can do everything else on my own. There's only 3 questions left, so
All right. Well, if it's okay, I guess we could stop here for today.
yeah.
All right. Well, glad to help here. I'll go ahead and stop the recording.